Welcome to the Restoration Voltage Control Simulator. The Restoration Voltage Control Simulator asks the user to pick up load with cold load characteristics, to energize long lines with large Faraday effect, to avoid ferroresonance effects, while keeping the voltage within emergency limits, at all location and all the time. The simulator checks the user's actions, and if this is not done correctly, will trip. The users will have to start over again. On top left, there is a print of the original load angle before the blackout. There are two power plants in service. The first one is set at 0% speed droop, so the users will not have to take care of the frequency. With this power plant, users will be able to increase manually the megavars output of the unit. There are 4 long lines with huge Faraday effect, 4 cap banks that are controlled with breakers. There are 2 radial set of transformers. Top and bottom ones there are 240 to 138 kV transformers. In series there are 138 to 25 kV transformers. All transformers are equipped with load tap changers that can be adjusted with wheels. Then there are distribution buses with feeders. The users have to energize all the lines, pick up all the feeders with cold load characteristics, while keeping the voltage within very close limits, at all time, and at every locations. The users have also to take care of ferroresonance effect. Ferroresonance will take place when there will be 2 transformers in series with no load. Let's go for an example. Look at the load curve, and at the voltage on the 240 kV. Now let's energize transformers and pick up some load. Check the voltage on the 240 kV and on the 138 kV bus. Users will have to bring down the voltage using the load tap changer, because it is exceeding the maximum emergency limit, the voltage being just below the maximum emergency limit. Close the breaker and see the effect. Check the voltage at every locations. We see it is at 228 kV, 122 kV, and 22 kV. We are all okay, so you can continue this level by yourself. So let's move to another level with different display. This seems to be a bit more complex. There are 5 power plants. The first power plant on the left middle is set at 0% speed droop, and there is a wheel to increase or decrease the megavars. For the other plants the megawatts and the megavars can be adjusted using wheels. There are lots of 240 kV lines, 240 to 138 kV transformers in parallels, and in series with these transformers 138 to 25 kV transformers, and then 25 kV buses with lots of 25 kV feeders. All transformers are equipped with load tap changers. All the feeders are with cold load characteristics. Be ready to face voltage alarms. Lines overloaded. Transformers overloaded. When energizing a transformer, be ready to face the transformer magnetization. Let's go for an example. The transformer magnetization will happen in a very short period of time. The users could energize the same transformer thousands of times. There will never be the same effect, due to the remnant magnetic field inside the transformer. Watch carefully the voltage, as the seconds will go by. Instantaneously. A second later. 2 seconds. Already at nominal voltage. Let's energize a line. Watch the megavars flow. As we all say, the voltage is kept at the same level, due to the AVR of the generating unit. Now let's energize a second line in series. More megavars flow. And due to the Faraday effect, voltage increases 238 kV on the second bus. Let's energize another transformer. Check the magnetization effect. A second later. 2 seconds. 3 seconds. And transformer magnetization is over. And now pick up a load. Normal load 11 megawatts. Due to cold load pickup, 58 megawatts and 38 megavars. The load on the feeders, as the cold load pickup characteristics, will change for each time users will begin a new simulation. Now you know enough. It's up to you to continue. We hope you enjoy this presentation. There are different levels with this category. From beginners to experts to ultra operators. At this level, this is no more a game. You might receive an electric shock,